Hello friends, welcome to Tech ARKIT YouTube channel. My name is Ravi. In this video session, we are going to see how you can deploy a production Kubernetes cluster. So how you can set up production Kubernetes cluster in real time. So that's the step-by-step guide we are going to see that. So how many servers required, what is the configuration you required, how to deploy in a cluster in a secured way. So that's what this session is all about. Let's see that. What are the prerequisites you require to set up the Kubernetes cluster? Minimum three servers with Ubuntu 22.0.04 LTS server OS, or you can also use the latest version, which is 23. So, but the 22 is the most stable version you can use for right now to deploy the cluster. So three nodes means three servers we required in the configuration. One is act as a master. It does not have any workloads on the master. So two, you have the two worker nodes which actually has the workload and deploys the configuration over there, right? You can add more nodes as per the requirement. Whenever you want, you can add the nodes based on your requirement, but a minimum three nodes which is required for to deploy the cluster. So master should have at least two CPU cores. That is the minimum of the requirement you should have for the hardware. But if you are deploying for the production, it should have a plenty of CPU cores and RAM. But the minimum one CPU and 4 GB RAM for the worker node. So that's the recommended option. The more than less than that, the server cannot actually run anything, the ports or anything. So here 10.x.x network, like 10 series network, should be available for the deployment, so that if you have any CIDR conflict, so you can resolve before deploying that. That is the recommendation. Allow port communication between the master and the worker node. So you have to have the port communication, but most of the times the master and the worker nodes have side by side connections when you deploy a initial cluster setup. So that's okay, like you can have master and nodes side by side nodes, and they have connected to the a similar network switch, so that you can they can communicate without any issues. But if you're deploying the worker node on the different location or the different network, so make sure that you have a network communication, the port communication enabled between the master and the worker nodes. So that's the stuff. So in this video, what we are going to see that, so we have the three parts, which the Kubernetes cluster deployment, and the part A basically have the preparing controller node and the worker nodes. Like you have to have the overlay file system and the net filters modules installed. Those are basically ensure that laying the file system overlay is a module, which is the kernel module, which helps the laying the file systems, overlaying the file systems. And the net filters basically requires to have the mascoding the rules of the firewall rules, kind of in between the port network and all this stuff. So those are the recommended settings by the Kubernetes. So those required to be prepared on the controller and worker node. And configuring the container runtime. So this is the CRI, which is very, very important and the main component to run the containers. Install kubeadm, kubelet, and kubectl. Those are the commands we are going to install on the worker nodes and the controller nodes as well. So on the part B, so we are going to prepare the controller node and initiate the API server and deploy the wave network. So the initiate the communication between the master and the controller nodes, so the master node and the worker nodes, so that they can create and join the cluster. That's the thing. And creating the cluster, the step part B. And the part C is all about the joining the nodes to the cluster, joining the nodes in the cluster. Then that's how you can verify that the nodes are joined to the cluster or not and make them work together. So that's the three parts: part A, part B, and part A, part B, and part C. So those are all going to cover in this same video. Let's, before going into the cluster deployment, just understand what are the components we have, what are the required components we need to have on the control plane components, the Kubernetes components. Like this has two mainly streams, like the control plane components as well as the node components. So control plane components has the basic of the cluster master components, and which has to be combined together. And which one is, first one is the kube API server, so which is called as the API server is the front end for the Kubernetes control plane. So example, if anybody wanted to talk with the Kubernetes cluster, the API server is the main component to, so that you can initiate the commands to talk with the API server. So anything like you want to deploy the ports, or you want to publish the services, or you want to do anything on that, so the API server is the component which needs to be communicated. etcd is the another component, so which is a highly available key value store. So basically storing your secrets and all this stuff, so which is a highly available key value store. So whatever the keys you want to store, or there, the etcd is the component which is used on the Kubernetes. Kubescheduler is the one another component, and the Kubernetes that watches for newly created ports with no assigned node and selects the node for them to run on. So actually, whenever you create a pods on the Kubernetes cluster, then if no node is assigned to that one, basically that's not happen. But if there is a pod is created initially, it is not assigned to any node, and the scheduler we actually watches whenever there is a new pod is created, and select an appropriate node, which node it does not have a load, or which node does not have a much ports, so that it automatically selects the suitable node for that port, then assign that port to that particular node. So that's the kube scheduler, is a component we'll do mainly on the cluster. Kube controller manager. So this is a very controller manager is a main important component after the API server, and this has a many roles involved here. So that runs controller processes. So all the controller processes will be controlled by this controller manager, something like the node controller, job controller, endpoint slice controller, service account controller. So there are so many other components which actually controller manager controls. So another one is the cloud controller manager. So this is basically used in a cloud environment. So if you deploy the Kubernetes cluster on the cloud, example AWS cloud or Azure cloud or GCP cloud, then so this cloud controller manager actually selected and used the appropriately on the cloud, so that you can optimize your Kubernetes cluster and make most available cluster on the cloud. So that's the cloud controller manager do. But we are deploying on-premises Kubernetes cluster, so the cloud controller manager is not much used. So that's the here. So there are node components as well. So when you install the nodes, so node also has some components which is called as one is a kubelet, an agent that runs on each node in the cluster. It makes sure that the containers are running in a pod. So make sure that the kubelet service is an agent, and on which is installed on all the nodes which are part of the cluster, and make sure that the containers are running in a pod. So in a pod, if you deploy one or two containers, so those are running or not. If it is not running, it is actually make sure that the container is runs. So that's the job of kubelet. Kube proxy. kubeproxy is a network proxy that runs on each node in your cluster, implementing part of the Kubernetes service concept. So that's the network proxy component which runs on in your cluster. Containers runtime. So the container runtime is a fundamental component that empowers Kubernetes to run containers effectively. So this is the main component, basically container runtime, which actually the bridge component between your container service, the basically the container service, and in the Kubernetes. So basically, whenever if you run the pod inside some containers with it, then this is the main component, so which empowers the Kubernetes to runs the containers. So the Kubernetes only initiate the command, but the container runtime makes sure that the container is running effectively. So that's the main component in the container runtime. So this is most of the dependent components and the major components in a control plane as well as the node components. Okay, let's go ahead and drive into the practical session and deploy the Kubernetes cluster, production cluster, and let's see how it goes. Here I have the three nodes. One is a master node, two has a worker nodes. One has 192, 168, 175.100 and 101 and 102. So one is in a control node, another two are the worker nodes I have here. So these are installed with the Ubuntu. Let's see that Ubuntu 22.043 LS, and that's a code of that one is Jammy. And so now let's implement the part one. So the part one can run on controller node as well as the worker nodes. To save the time, so I'm using the mobile extreme client to connect to the servers. So it has a multi-execute option so that I can execute the commands on the multiple server at the same time. So that I'm executing this one. The multi execution mode so that I can execute the same commands on three nodes at the same time. So to save the time, the first command is going to be the doing the overlay and BRNET filters component on the servers. So these are the commands. So I'm just going to paste this one, show content in menu, and paste it here, right? So this is the component. So let's paste it here and let's paste it here. So now I have pasted this the first net filter on the here on the three nodes that created the file called /etc. So let's cat that file. So it has a modules load.d and a kts dot configuration file. So this is the overlay and net filters module I'm going to insert into the kernel. Sudo. So now do the mod prop means that I'm just modifying the kernel module which is overlay, and again do the mod prop, do the br underscore net filter, so which is the two modules we are going to install it. So now you can see that the module BRNet filter not found in a directory, so we have to install the supported packages here to in order to do this supporting of this library module, right? So because the server is installed with the minimal configuration packages, so it does not install with the geo or anything, so that optimizing the performance. So that's why we have to install this module here. So let's install that module fast. So the module we need to install is sudo apt install ebtables, so which is the component we need to install in order to solve that above issue. Okay, so once this is done, we are going to run that module again and see whether it is able to do that or not. Okay, sudo mod prop and do the br underscore net filter. Now you can see that the error is gone. So that's the two modules we have to do this. So one is an overlay file system and another is an a net filter module insert into the kernel. So that's the components. Now we have to add the another two values onto the sysctl KTS, which is going to be the right here and the enter, and I have the another component here and paste it here. So these are the NetBridge IP tables values we are going to insert into the system CTL, and now type the sudo sysctl hyphen system and verify the whether the values has ones in all the servers. You can see that NetBridge NF call tables equal to 1 and NetBridge calls IP6 tables equal to 1 and IP forward equal to IPv4 forward equal to 1. So this is the three components which is required for your making the network communication between the nodes and the ports and the overall stuff. So let's see ls mode and see the overlay and net filters module which are inserted into the kernel or not. Okay, so this is overlays looks good, and again filter with the br underscore net filter value, so that if you see both of them are good, then yeah, looks good on the three servers. So those are the two modules looks good. The value is nice, and verifying the system CTL components like sysctl netbridge dot bridge nf call. So just now we inserted that components, so we are verifying them that they are showing the right values or not, so that it should be show the right values. Otherwise, if you reboot the server or try to install the server components, it actually not works. So that's why we are just verifying the IPv6 tables and net IPv4 IP forwarding values, so that we could able to check these values are 1. So you can see that all the values on three nodes are 1. So that's very good. So all components as of now, nice, working fine. So now let's try to update the packages, the cache in all the servers by doing the apt update, so that it will update the latest package caching information on all the servers. Now let's install some required packages. Apt install ca certificates. So this is the certificates required for your secure communication between your servers, and GNUPG is the encryption method which uses on all the components communication. So now you can see those are the components is already installed. Now just install the /etc apt and key rings. So that's the directory permissions. Now you can just curl the downloading the GPG packages and then install that GPG component here. So let's do the curl from the website. So F yes, a small s and capital S L, because this is going to be the HTTPS component, so that ignoring the SSL certificate. So now do the GPG, sudo GPG, and passing the command output to here, and dear more -o options /etc apt and key rings. Just we done the that directory and say docker dot gpg. So that is the component we are going to do here. Let's curl that configuration drmor. Okay, so now sudo, let's check the permissions. So a plus r, so which is adding the read permissions to that apt, and keyrings directory docker.gpg file. That's it. Now add the Docker repository to the apt resources, so that you could able to install the Docker in all the servers. Okay, so now let's do the multi-paste here and enter. So now it's add the component, the repository. Then after that you have to again run the sudo apt update, so that it will update the local caching information by fetching the remote package list. After that, so you can install the Docker. So the Docker, installing the Docker, again I'm doing the multi-paste component here. You can see that install the Docker CE, Docker CE CLI, and container D compose plugins, Docker compose plugins on all this stuff, and let's install them. So you have to install on all the three nodes. Um, so that you can just verify the Docker components by just running the hello world image on all of these servers, so that you should make sure that the Docker is running fine. So that's the major component. The container runtime should be running on the Docker is running on all the nodes, so that you could able to run the containers inside the pods from the Kubernetes. Okay, so let it install the um, required components from that. Then we will do the run some first hello world here, so that we can verify that the Kubernetes cluster could able to do that all this stuff. Okay, now you can see all three nodes has been completed their Docker installation, and let's try to run some command here, hello world. So Docker hello world, so that it could able to download and run that hello world container in all the servers, so that it makes sure that the Docker is working fine. It looks like, let's run the Docker ps-a. Okay, it has some permission issue. Okay, sorry, I have to run something sudo. So yeah, all are running perfectly fine. So they are absolutely fine. We could able to run that. And let's see, run as some root components. We require to run some container D commands as a root. Let's clear the command and let's jump into the root by switching the root. Let's run the container D default configuration. Do the multi-paste it here. Container D config, the default configuration file is going to be created on this config.toml on the /etc container d config.toml. So create the default container d configuration file. So that's the main thing we are going to do. And let's edit this component on all the servers, which is going to be the container d config.toml. And here let's change the system group C group equal to true. So just locate the group. So that is the value here. And now from false to make it true. So C group's value should be true. Now save this and systemctl restart container D. This is the service. We have to check the status. Just verify the container D does not have any errors. So looks good. So now let's clear the screen. Now we have run some configuration, container D configuration over there, and we could able to do that perfectly. All right. Ensure that this the components are running on all the nodes, right? So let's install the kubeadm and kubelet and kubectl commands on all the nodes. So which is required kubeadm command to the bootstrap the cluster, and the kubelet, the components should be running on, the agent should be running on all the nodes. Kubectl is the command utility to talk within a cluster to anything running from the backend, right? So that's the, and I'm just going to do the apt update. I'm going to install the remaining stuff here. Let's run it. So now done. So adding the Kubernetes repos to the apt source. So that's what again we are going to do with this command. Let's now again run the apt update so that it will update the local cache information from the packaging listing with the new repository. So now we have added all this configuration. Let's clear the screen. Um, so let's run the kube ADM, kubelet, and kubectl install on these three nodes. So apt get install kubelet, kubeadm, and kubectl. Those are the required components on all the three servers. Let them download. So the CRI components and required tools to be installed. So that is the container runtime required to install on all the servers so that you can maintain the Kubernetes. Controller node completed the installation. Let's see, remaining two nodes is still downloading the kubeadm and kubectl. Done. So all the nodes has been installed. To make sure that we log the versions, so how about the automatic updates on the nodes so that they have the mismatch in the versions of the kubelet, kubeadm, and kubectl. To log that version, so we have to mark them as hold for the component so that it won't actually do the updates from the apt. So we are just making sure that they have the correct versions on the all the three servers. So this is the part A. So we have completed the setting up the overlay and net filters and install the Docker and install the container D service, and we have installed the kubelet, kubeadm, and kubectl on all the servers. Now let's break this multi-execution mode and we'll try to install the remaining components as an individual. So now we're going to do the controller node. So we should make sure that we are in a root user here and initiate the API server configuration here. Okay, so to do that, so we have to run the kubeadm command, which is the kubeadm. So we are initializing the kubeadm, which is initialize the basically the cluster information, right? With the API server, advertise on, advertise means expose on that particular IP address equal to, so the controller IP address we have to provide 192.168.175.100. That is the um, controller IP address, controller server IP address, and the port network we are going to set up. So anything you can set up here, but basically required the information which series you wanted to set it up. You can set it up that, but I am giving something like 10.244.0.0 slash 16. So this much network would be more than enough for to run the nodes and the pods and the containers on this information. So now let's, so it will actually pull some information on the API related pods, then run those pods as a for the API server advertising on that particular IP address, then set up those node inform the CADR network information. Okay, it is bringing those registry information from the sandbox. So let's wait for some time to pull those containers and let them install. It will take some time based on your internet speed. So the deployment says that kubelet is not running healthy. Let's verify the kubelet status here. Um, what is the status of kubelet? So the kubelet is not running. So Kubernetes agent node agent is not running over here. So that might be the issue here. So let's fix that issue so that we can able to run it. So this is not running. Like there might be the issue with the Docker container, something like that. Kubernetes is not running. So let's make the directory, which is basically does not exist by default. Let's verify that the Docker uh, is there or not. Let's go /etc Docker. Okay, it is exist, but there is no file is there as a daemon to actually run it. Let's make that file the daemon.json file and some configuration information over there. So this is the configuration information. Let's paste it. Now if you go to the /etc docker and you can see the JSON file, the daemon JSON file has the information. Now let's say sudo systemctl. So we are already in root, no need to basically run sudo, but just make sure that it's enable the docker and systemctl daemon reload, so that just reload the configuration information. Sorry, there's a spelling mistake here. Now just restart the docker again, uh, in place of enable, just put it as restart. Now let's kubeadm reset. So just reset the kubeadm. So deleting this kubelet and all this information has been done. So now let's reinitiate that kubeadm command again, so that we could able to run this one. So initiate the kubeadm again. Let's see, it should be completed fast right now. Okay, it's going very much quicker. So it should complete the installation, the bootstrap information, bootstrapping the Kubernetes should be done perfectly. So it might be sometime the swap issue as well. So let's run the swap disabling over here and let's edit the fstab entry, and if it is has any swap, let's make sure that it disconnects from this, and systemctl status kubelet. Okay, kubelet is running fine. Now let's reinitiate that command and see it should work now. Okay, so we have to reset this one again. Uh, Cube ADM reset. Then reinitiate this. Okay, now Kubernetes control plane has been initiated successfully. Okay, make sure that you disable the swap configuration, the swap. Otherwise, the Kubernetes is not able to run it perfectly. So that's the error here. So make sure that you disable that one. Okay, so that's the controller node configuration, and we have to exit from the root user and run some commands from the normal user. Okay, so those are the commands which is already given here. So this is called making the directory, adding the user basically to the kubeconfig, that is the stuff here, and sudo copy this kubeconfig configuration to that recently created directory, and provide the password. Now change the ownership of that configuration file to the user which you are currently in. So now, so we have made the kube directory and copy this admin.config file to that kube directory and make this owner and group to that particular directory. So that's the step, and deploy the wave network, and we have to run kubectl apply, and this is the ML file we have to apply to deploy the wave network. So now you can see which is has been deployed successfully and created. Now again switch back to the root user and just run kubeadm token create hyphen print the join command, so that we just run this command and get the join command and paste it on the nodes so that they can join to the cluster. So this is the token value with the join command. That's all. We done the part B, and let's run the part C, like adding the workers into the cluster. So this is the command. Just copy this command and paste it on the servers. Okay, so it should be normal user. If it is sudo, then you have to execute as a sudo, then enter it here. So then it actually bootstraps and join to the cluster. So if you are already in your root user, just copy paste the command and execute it. So it will make sure that the worker nodes joins to the cluster. Issue. Okay, let it terminate. Then we'll switch off the swap and rerun the command. Okay, so now let's execute the swap af command in the server. So it will disable the swap. Let's see, this is not came yet. And create the docker daemon file and specify those configuration, so that we will make sure that the docker should be able to run the daemon perfectly. Okay, let's paste this one. And now system CTL, enable the docker system CTL daemon reload, so that the configuration will be applied. System CTL restart the docker. Now let's reset kubeadm reset, so that it won't actually remove the existing configuration, and run the joining command again. Let's join this one. Now you could see that this is joined to the cluster perfectly. All right. Now this is also hit with the same configuration. Now let's see swap of -a, so it will disable the swap, and make sure that you comment this etcfs file as well, so that it won't actually re-trigger the swap file again. So make sure that you disable this one. And here again I'm just make the docker configuration file, that is the JSON file. Now execute the systemctl enable docker systemctl daemon reload systemctl restart docker, and reset the kubeadm, so that it reset the information what try to deploy in the free flight information, and rerun this command which we join to the cluster. And make sure you have to disable the fstab entry, so that it won't re-trigger the swap information. Now let's execute this kubectl and get nodes on here, so that you could see that, sorry, we should be execute from the normal user. So we set up the kube configuration here. So now you can see that node 1 is ready, controller node is control plane is ready, and node 2 is not ready, getting ready. Okay, so now all the cluster controller is ready, node 1, node 2 is also ready, worker nodes also is ready, and our Kubernetes is ready to rock. Okay, let's see some deployments and service publishments in the next sessions, how we can do that. That's about it, guys. Thanks for watching. Stay tuned. Please make sure you follow the remaining steps, all the steps step by steps, so that you could able to set up this production cluster environment, the Kubernetes cluster environment. Thanks for watching. Stay tuned. Please subscribe to the channel for more upcoming videos and courses.